Good morning, everyone. A very good morning to all of you, bacho. We are live. We are back on exam dos. We are back with the ESE Officer Practice Series for Engineering Services PYQs. And I'm live here in front of you with the part 5 of our Control System Series. कंट्रोल सिस्टम का पार्ट 5 लेके आप सभी लोगों के सामने मैं हाजिर हूं. फटाफट सभी लोग आ जाइए भाई. कम ऑन एवरीबॉडी, क्विकली ज्वाइन. Today we are going to have 2 sessions on control system and tomorrow this series is going to be over. Okay? चलिए. So without wasting any time, let me get started. Okay. So loop transfer function is given. It is asking the root locus diagram. So if you see, poles are at 0 and plus minus J4. Zeros are at plus minus J8. Now, what is the correct root locus? Basically, okay, one pole is here, other is at 4, and the zeros are at J8. These are my zeros. Now, beta, by the rule number 3 of root locus, the part of real axis to the right of which there are odd number of poles and zeros lies on the root locus. रियल एक्सिस का वो हिस्सा जिसके राइट में ऑड नंबर ऑफ पोल और जीरो आते हैं वो रूट लोकस पे लाई करता है. So if you see the red line to the right of it, there are 5 poles and zeros. इसके राइट में 5 पोल और जीरो हैं. For any complex pole, I need the angle of departure. So I will connect it to the remaining poles and the zeros. I will connect it to the remaining poles and the zeros. The angle from the upper zero is minus 90, 90, 90, 90. Now phi is summation of angle from 0 minus angle from pole. From 0 it is minus 90 plus 90. From pole 90 plus 90. So that is minus 180. Angle of departure is 180 plus phi. That is 0 degree. So basically it will depart at 0 degree, that is to the right, and it will terminate at a 0. So this should be the root locus. So answer should be D. D आएगा. समझ गए? For complex pole, always check the angle of departure. Next, the breakaway point. For breakaway point, ESE 2011, form the characteristic equation. Then find K. Then keep dk by ds equal to 0. So S equal to minus 1 minus 3. Only one will match minus 1. Minus 1 match कर गया. Consider the following statement regarding the root locus. When k is 0, the roots coincide with the poles. Yes, actually open loop pole. K is increased. The root locus moves away from the pole. Yes. It is symmetric about imaginary axis. No, about real axis. Why? Because complex roots always exist in conjugate pair. Number of branches terminating at infinity is p minus z, not p plus z. P minus z. So answer is 1 and 2. ESC 2011. ESC 2012. Angle between the asymptotes. Two adjacent asymptote. One 360 by p minus z. Okay, how? Suppose phi 1 is this. For the next asymptote, you keep q plus 1. Q is a natural number. For successive asymptote, you increase q. Q आपका एक natural number है, बल्कि natural क्या integer है. Q basically belongs to 0 up to p minus z minus 1. So for two successive asymptote, you will increase the value of q. Now phi 2 minus phi 1 will be 360 by p minus z. ESC 2012, addition of open loop poles does what? Root locus shifts towards imaginary axis. Basically shifts right. Or you can say stability reduces. So when you add poles, your stability goes down. ESC 2012, the breakaway point. Breakaway point always lies on that section of real axis which lies on root locus, and it lies between two poles. ब्रेकअवे पॉइंट रियल एक्सिस के उस हिस्से पे आता है जो रूट लोकस का भी हिस्सा है और दो पोल्स के बीच में. नाउ व्हाट इज द कंडीशन ऑफ द रियल एक्सिस टू लाई ऑन रूट लोकस? टू द राइट ऑफ दैट रीजन there should be odd number of poles and zeros. So here 3 and here you can see 1. So this is real axis between two poles and part of root locus. Therefore breakaway point exists. So what should be the answer? ऐसा क्यों होता है बेटा? Branches originate from both the pole and they will coincide here. So there will be a breakaway point. There will be a breakaway point. The network function ns is denoted by a scale factor multiplied with the ratio of zero factor and pole factor. It is like this. Correct? That is how you define a rational function. Correct? When there are n zeros m poles, the poles at infinity of multiplicity n minus m. Similarly, when n is less than m, यानी 0 less than pole, zeros at infinity m minus n. तो मैंने बताया था ना, ESC 2012 है. Always poles and zeros are equal. So to balance their number, some poles or zeros will lie at infinity. If pole is greater than 0, p minus z, zeros at infinity. If 0 is greater than pole, z minus p, poles at infinity, to make the number of poles and zeros equal. पोल और जीरो इक्वल करने के लिए कुछ पोल और जीरो इंफिनिटी पे होते हैं. ESC 2013, number of asymptote and the centroid. I told you how to modify this. Take the terms of k separately, divide by rest of the function. So it is 1 plus GSHS equal to 0. So poles are 4. So number of asymptotes is 3. Now centroid. You add the real part of the poles. 15 minus 4 would be 3 and minus 4 comma 0. Centroid is summation of poles minus summation of zeros by P minus Z. Which of ESC 2014, which of the following point is not on the root locus? ठीक है, तो कंडीशन क्या होती है? For a point to lie on root locus, it must satisfy angle criteria. इसको एंगल क्राइटेरिया सेटिस्फाई करना पड़ेगा. ओके, दैट इज angle of GH odd multiple of 180. Okay. Now, if I check A, minus J, for denominator use minus sign, minus J is minus 90, 1 minus J root 3, fourth quadrant, 3 minus J root 3 again, fourth quadrant. Therefore, this lies on root locus. ये root locus का हिस्सा बनेगा. So while taking the angle of the complex number, always check the quadrant. The portion of real axis that lie on the root locus are between. So again, beta, ESC 2015, we can check the portion of the real axis that lies on the root locus by rule number 3. So pole at -1, -2, 0 at this. So which part of the real axis will lie on root locus? This part. Because to the right of this, there are 3 poles and zeros. This part. Because to the right of this, there is 1 pole. So -1 and -2 and -4 and minus infinity. B. Consider the following statement about root locus. Symmetric about real axis? Yes. Why? Complex roots always exist in conjugate pair. Root locus moves along the real axis from open loop pole to 0 or infinity. This is called real root branch. अगर branch real axis पे lie कर रही है, so that branch is representing the real root of the characteristic equation. If the branch is basically moving along the real axis, it represents the real roots of the characteristic equation. Breakaway point are the solution of dk by ds equal to 0. dk by ds equal to 0. So all are correct. ESC 2015. Again ESC 2015. The open loop transfer function is given by this. Asymptote of the root loci for large value of k meet at a point in the S plane. So asymptotes always meet at centroid. Asymptotes always meet at centroid. How to find centroid? Add the poles. -2 b square 16 minus 4ac 32. Zero is at -8. Poles are 4, zeros are 1. So -4 minus basically 12. 4 or 6, 10. 4 and 4, 8 actually. -8 plus 8. 0. So answer is C. 0, 0. Okay, the answer is C. ESE 2015 inverse root locus is the image of direct root locus. Root locus is symmetric about imaginary axis. Okay. So this is not, it is symmetric about real axis. ESE 2015. Inverse root locus, yes, it is the mirror image. Centroid is the point where root loci break from real axis. No, that is called as break point. Centroid is the point where asymptote intersect. Correct. Absolutely correct. Again, ESE 2015, at breakaway point system is critically damped. Correct. Why? Breakaway point is what? Point where multiple branches of root locus intersect. Now, each branch of root locus represents a closed loop pole. So, at breakaway point, multiple closed loop pole coincide, and when your poles are repeated, that is critically damped. So beta, each branch of root locus basically represents a closed loop pole. At a point where root locus intersects with the imaginary axis, system is marginally stable because it means roots of characteristic equation are imaginary. But the two statements are not related, therefore B. ESE 2015, a root locus is obtained using closed loop pole. It is plotted using open loop pole. देखो, रूट लोकस की हर ब्रांच आपको ये बताती है कि क्लोज लूप पोल कहां पे है, लेकिन इसे बनाने में कभी भी क्लोज लूप पोल का इस्तेमाल नहीं होता. वी ड्रॉ इट यूजिंग द ओपन लूप पोल. ओके, ईच ब्रांच of root locus represents closed loop pole, but we never use closed loop pole to construct root locus. ठीक है, रूट लोकस बनाने में इस्तेमाल नहीं करते. ESE 2016, addition of a zero pushes the root locus to the left. Correct. Addition of pole pushes to the right. CRL refers to root loci with positive K. No, negative K. Addition of a zero reduces the maximum overshoot. Correct. Okay, 1, 2 and 4. ओवरशूट कम हो जाता है, जीरो ऐड करने से, पोल ऐड करने से बढ़ जाता है। ESE 2016. While forming a Routh array, the situation of a row of zeros indicates that the system has symmetrically located roots. ESE 2017. Symmetrically with respect to imaginary axis. Okay. ESE 2018. Which of the following is considered as a time domain technique? Root locus and Routh criteria. Both are time domain. Both are time domain. The open loop transfer function of a root locus plot as shown. So beta 4 branches originate at s equal to -1. Therefore 4 poles lie at, because from one pole only one branch originates. एक पोल से एक ब्रांच निकलती है, तो अगर एक पोल से 4 ब्रांच निकल रही है, इट मींस दैट देयर इज अ फोर्थ ऑर्डर पोल. ESE 2020. If the number of zero are less than the pole, transfer function becomes 0 at s tending to infinity. So there are zeros at infinity. Order of 0 is p minus z. अभी बताया ना मैंने, if poles are more than zeros, then their difference is the number of zeros lying at infinity. If poles are less, so that many poles will lie at infinity. If zeros are less, that many zeros will lie at infinity. ESE 2020. The method of determination of stability of a feedback system as a function of adjustable gain parameter, which does not provide detailed information regarding location of closed loop pole, is root locus. ये कह रहा है ऐसा मेथड जो स्टेबिलिटी बताता है as a function of adjustable gain. So in root locus, my gain is variable. Okay. And by looking at the root locus, if it is in the right half plane, I can say the closed loop pole lie in the right half plane unstable. If it is in the left half plane, I can say closed loop poles lie in the left half plane stable. So stable, unstable I can judge as a function of k in root locus. ESE 2020. By addition of the poles, root locus shift to the right and stability decreases, correct? Addition of 0, root locus shift toward left, stability increases, correct? Addition of 0, stability remains the same, no, it increases. Okay. ESE 2020. Consider the following system, the angle of asymptote and centroid. So what is my GSHS? So how many poles are there? 3. How many zeros? None. So angle of asymptote is 60, 180, 300. Centroid. Add the poles minus zeros by this. So -1. See. ESE 23. The number of branches of root locus equal to the closed loop pole. Yes. Each branch represents one closed loop pole. Symmetric about real axis? Yes. Because complex roots are existing in conjugate pair. As k tends to infinity, branches of root locus tend to asymptote. That is the definition of asymptote. Asymptote is the tangent to the graph at infinity. एसिम्टोट ग्राफ को टच करता है इंफिनिटी पे। नेक्स्ट ESE 23, रूट लोकस इज द पाथ ऑफ द रूट्स ऑफ कैरेक्टरिस्टिक इक्वेशन ट्रेस्ड आउट इन द एस प्लेन as a system parameter varies from 0 to infinity. Yes, that is the definition of root locus. रूट लोकस कैरेक्टरिस्टिक इक्वेशन के रूट्स का लोकस है, पाथ है, जैसे जैसे सिस्टम का गेन वेरी करें। फ्रीक्वेंसी रिस्पॉन्स इज द स्टेडी स्टेट रिस्पॉन्स टू अ नॉन साइनोसोइडल, नहीं साइनोसोइडल इनपुट। फ्रीक्वेंसी रिस्पॉन्स के लिए इनपुट क्या लेते हैं? साइनोसोइडल। ठीक है, तो आंसर इज सी। ESE 24, which statement is correct regarding root locus? It can be used to analyze and design the effect of loop gain upon system performance and stability. Yes. रूट लोकस से परफॉर्मेंस स्टेबिलिटी दोनों को एनालाइज कर सकते हो। व्हाई? बिकॉज परफॉर्मेंस मींस वी नीड जीटा, ओमेगा एन, these can be computed from root locus. Stability by observing whether root locus belongs to right half plane or it belongs to left half plane. चलिए, now we come to the frequency response. The phase varies between at omega tending to 0 square of j omega at omega tending to 0, so angle is 0 degree. At omega tending to infinity, basically angle is 90, zeros minus pole. Because at infinity each zero contributes the angle of 90 and each pole contributes the angle of minus 90. इंफिनिटी पे हर एक पोल माइनस 90 का एंगल देता है और 0 प्लस 90 का एंगल देता है, एंड दैट इज हाउ आई हैव रिटन द एंगल। ESE 2001, transfer function is given by GS equal to S by 1 plus S. We need the Nyquist plot, or you can say polar plot. So magnitude omega by and phase at omega tending to infinity. इंफिनिटी पे आप नीचे से 1 इग्नोर कर दो, तो इट विल बी ओमेगा बाय ओमेगा 1, and tan inverse infinity will be 90. 90 minus 90 is 0. So phase from 0 to 90, it is first quadrant. Okay. So B आएगा। ESE 2001, the Nyquist plot of a servo system is given. So this is a very famous Nyquist plot. It is type 1, order 2. How did I judge this? This is called as the tail. Basically, ये एरो ऐसे होना चाहिए, and this is the head. So angle of tail is minus 90 into type, which is shown as minus 90. Angle of head minus 90 P minus Z, which is given as minus 180. So P minus Z is 2. If you ignore zeros, so there are 2 poles, so order is 2. So the result will be P. ये 2 poles हैं, दोनों से branch चली and then it breaks away. So branch originates from the 2 poles, then it breaks away. Okay. If the Nyquist plot ESE 2001 cuts the negative real axis at point 4, gain margin. Gain margin is 1 by gain 2.5 D. Okay, match the transfer function with the polar plot. Type 1, order 2. अभी मैंने बताया ना इसका कैसा आता है. Second. Type 0, order 2. So angle of tail will be 0, angle of head will be minus 180. 4. Type 1, order 3. The most popular. Type 1, order 3 first. Type 2, order 4. So head angle will be minus 180. Sorry, tail angle will be minus 180. Head will be minus 360. That is 3. 2, 4, 1, 3. ठीक है. ESE 2002. टेल और हेड का एंगल पता है ना, तो आप पोलर प्लॉट बना सकते हो इजीली. ESE 2002. Consider the Nyquist diagram. The transfer function does not have any poles and zeros in the left half plane. Sorry, right half plane. So if minus 1 lies in the region 1, so minus 1 comma 0 encircled twice clockwise. Okay. If it is encircled twice clockwise, n equal to minus 2, which is P minus Z. Since no open loop poles in RHP, P is 0. So Z is 2. So 2 closed loop pole in RHP. So unstable. Okay. नहीं, मुझे लगता है ना कि ये वाले एरो पलटने चाहिए थे, तभी ये रूट लो, तभी ये नाइक्विस्ट कंटिन्यूअस बन पाता लाइक दिस. एक्चुअली तो एक क्लॉकवाइज एक एंटी क्लॉकवाइज, कोई एनसर्कलमेंट नहीं आता, तो इट विल बी स्टेबल. देखो ना, एक एंटी क्लॉकवाइज और एक बड़े वाला क्लॉकवाइज. रीजन 2, इफ इट लाइज हेयर, तो minus 1 will be encircled twice anti-clockwise. Sorry, clockwise. Encircled twice clockwise. So n is equal to minus 2. Two closed loop pole in RHP, it is unstable. Okay. If there are two closed loop pole in RHP, it is unstable. So if we go from region 1 to 2, we are going from stable to unstable. 1 से 2 जा रहे हो तो स्टेबल से अनस्टेबल आप जा रहे हो। ओके, Bode phase plot is given, the type of the system is. So if you see initial phase, therefore type 0. Type is type into minus 90 is initial phase. Okay, next. TSC 2003. Nyquist plot of this function for k equal to 1 is given for the system to be stable. The value of k should be. If you see beta, two poles of open loop transfer function lie in RHP. So P is 2. For closed loop stability, no closed loop pole should lie in RHP. कोई भी क्लोज लूप पोल RHP में नहीं जाना चाहिए. Therefore Z equal to 0. Now N is P minus Z. So encircle minus 1 comma 0 twice anti-clockwise. So it should lie here. तभी तो minus 1 comma 0 दो बार एंटी क्लॉकवाइज एनसर्कल होगा. तो minus 1.33 k should be less than minus 1. माइनस 1 से लेफ्ट आ रहा है, लेफ्ट माने लेस होता है, तो k ग्रेटर देन 1 by 1.33. D. ESC 2003, the Nyquist plot is omega tending to 0 tail. Angle is minus 180. So type is 2. Omega infinity is head. Angle of head is minus 360. So order is 4. So D option. And a type 2 order 4. ESC 2003. The pole 0 map and the Nyquist plot is given. So pole 0 map is for open loop system. All poles are in left half plane. So P is 0. No pole in RHP. Since all pole are in left half, it is stable. So here minus 1 comma 0 encircled twice clockwise. So two closed loop pole in RHP. Unstable. B. दो क्लोज लूप पोल राइट हाफ में जा रहे हैं, इसीलिए अनस्टेबल बनेगा. पीक मैग्नीट्यूड इज, so the format is like this. So omega n square is 100. Omega n is 10. (10√2). Zeta is 1 by √2. Okay. So that is 1. This is called as resonance peak. That is 1. ESE 2004. Consider the system shown in the figure. Now this is a sinusoidal input. Whenever we have sinusoidal input whose frequency is 1, omega naught is 1. So first of all, convert Hs to Hj omega. Now put omega naught equal to 1. Convert to magnitude and angle. Numerator angle is 90. Denominator tan inverse 1. Tan inverse 1 is 45. 90 minus 45 is 45. Now output is magnitude is multiplied with sine and angle is added. So 45 will be added. 1 by root 2 sine t plus 45. मैग्नीट्यूड मल्टीप्लाई होता है बेटा, एंगल ऐड होता है आपका. मैच द टाइप ऑफ प्लॉट एंड द फंक्शन. बोडे पोलर नाइक्विस्ट निकोल्स चार्ट. ओपन लूप रिस्पॉन्स ड्यू टू डैम्प्ड साइनोसोइडल इनपुट as a function of complex frequency. Open loop response due to undamped sinusoidal function as a function of real frequency. देखो सेपरेट मैग्नीट्यूड और फेज एंगल, दिस इज बोडे प्लॉट. ओके, देन यू हैव पोलर प्लॉट, नाइक्विस्ट प्लॉट, निकोल्स चार्ट. कॉम्प्लेक्स फ्रीक्वेंसीज नाइक्विस्ट प्लॉट, क्योंकि यहां जे ओमेगा के अलावा वी ऑल्सो हैव इनफाइनाइट सर्कल. ओके, this is polar plot. Undamped y because s is j omega. Sigma is taken as 0. And closed loop response is Nichols chart. So basically Nyquist plot 1, polar plot 2, 3, 4. 4, 2, 1, 3. ESE 2004. A unity feedback control system has a forward path transfer function. Phase is 0 at omega 1. So first convert to j omega. This is 0. Now take tan both side. Tan pi by 2 plus theta is minus cot theta. Okay. Minus minus cancel. Tan omega t is 1 by omega. ठीक है, कॉट और टैन इनवर्स की वजह से रेसिप्रोकल हो गया बिकॉज कॉट थीटा इज 1 बाय टैन थीटा. ESE 2004 Nyquist plot of the closed loop control system with the loop transfer function. So this is beta type 1 order 2. -1, 0 is never enclosed. इसको सोचने के दो तरीके हैं, या तो आप प्लॉट बना लो. This is the polar plot. The mirror image is the inverse polar. Due to type 1, there is one clockwise infinite semicircle. So minus 1 is not enclosed. Or second order system, all coefficient positive, always stable. So Z equal to 0. Here no pole in RHP. So P is 0. N is P minus Z, 0 minus. दोनों तरह से सोच सकते हो, ग्राफिकली भी और मैथमेटिकली भी. ESE 2004, a minimum phase unity feedback system has a constant slope minus 20 dB. The maximum value of phase margin minus 20 dB per decade means pole at origin. So GS is K by simple. Phase margin. अब phase margin कितना आएगा बेटा बताओ? What will be your phase margin? -90°. B. ESE 2004, consider the following Nyquist plot of a feedback system having open loop transfer function. So one pole in RHP. So P बराबर 1. Number of closed loop pole in the right half plane. Number of closed loop pole in the right half plane. अब यहां पे हमको ये देखना पड़ेगा कि -1 कितनी बार एनक्लोज हुआ. तो बेसिकली अगर ओरिजिन का एनसर्कलमेंट देखते तो भी 1 आता. 1 का मतलब है एक बार एंटी. -1 को तो यार यही कह सकते हो कि एक बार क्लॉकवाइज. तो n इक्वल टू -1. तो Z मस्ट बी 2. 2 क्लोज लूप पोल इन RHP. ऐसा आप बोल सकते हो. Consider the following statement ESE 2004 regarding Nyquist plot with counterclockwise Nyquist path. Counterclockwise Nyquist path माने contour is anti-clockwise. So n positive माने if you change the contour instead of clockwise, you take anti-clockwise. The sign convention of n also changes. अगर कंटूर की डायरेक्शन बदल दी ना क्लॉकवाइज के बदले एंटी क्लॉकवाइज, तो जो n के लिए साइन कन्वेंशन चलता है वो भी रिवर्स हो जाएगा. For a stable loop system, Nyquist plot should encircle -1 as many times as the poles of GSHS in the right half plane. So n equal to P minus Z. It is saying n equal to P. Therefore Z equal to 0. Therefore Z equal to 0, जो कि correct है. If the loop gain is a stable function, the closed loop system is always stable. GSHS अगर stable है, it means if P is 0, Z is 0. No, not necessary. Not necessary. If the loop gain function is a stable, द नाइक्विस्ट प्लॉट, यानी कि अगर P 0 है तो N must be 0, therefore Z equal to 0, so that closed loop system is stable. So basically C, 1 and 3. Okay. Match list 1 with the related parameter. Root locus plot, breakaway point. Bode plot, corner frequency. Nyquist plot, critical point. Signal flow, transmittance, that is gain. 2134. This is from ESE 2012. Next, Nyquist plot of a loop transfer function with respect to the gain margin does not intersect negative real axis. यानी ओमेगा PC not applicable. So gain margin is infinite. Phase crossover frequency नहीं आएगी तो gain margin will be infinite. Intersects negative real axis between 0 and P. So gain margin is positive. Positive. It is stable. Passes through minus 1 comma 0 marginally stable and closes minus 1 comma 0 unstable. 2 3 4 1. Okay, 2 3 4 1. अगर ये वाला पॉजिटिव होता 2 1 4 3, ये चल जाएगा. Next, ESE 2005 again. Encirclement of origin of 1 plus GS corresponds to encirclement of a point in minus 1 plus GS. So origin in 1 plus GS means so it is minus 2. तो 1 प्लस जीएस में जो ओरिजिन वाला पॉइंट है वो माइनस 1 प्लस जीएस में माइनस 2 बन गया. ओके. Breakaway point ESE 2005 is associated with root locus. Phase margin is calculated at gain crossover. Gain margin at phase crossover. Second order system stable. 4 3 2 1. ESE 2005, the variation in gain does not alter the phase plot in a Bode diagram. Yes, it only affects magnitude plot. Phase margin is not affected by variation of gain. Wrong. Basically, omega GC varies. If gain changes, the omega gain crossover varies. So phase margin vary. Phase margin will vary. ESE 2006. All the system which exhibit overshoot in transient response will also exhibit peak in frequency response. No. Overshoot का condition है जीटा less than 1 और peak का जीटा less than 1 by root 2. तो मान लो कोई सिस्टम का जीटा है 0.9, it will exhibit overshoot but not peak in the frequency response. Large resonance peak means zeta is less, also corresponds to large overshoot. जीटा लेस होने से दोनों ही बड़े आते हैं. System function has a pole at 0 and 0 at minus 1. Constant multiplier is unity. Excitation is cos t. Now again, it is ESE 2006. Whenever you have sinusoidal input, put S equal to j omega. For sinusoidal input, put S equal to j omega. phase is minus 45, multiply magnitude and shift the angle. Cos theta is sin 90 plus theta. So A. Consider the following statement. The gain crossover is the point where magnitude is 1. Magnitude crosses 0 dB. Absolute value is 1. It means 0 dB. Magnitude versus phase plot touches the 0 dB loci again. Because magnitude is 0, it will touch 0 dB locus. Okay. Now this is the tail. Angle of tail is minus 90. Type 1. Type 4. Okay. Angle of tail minus 180. Type 2. टाइप 4 की जगह इसको टाइप 0 भी कह सकते हो. ओके, तो 2 1 3 2 1 3 बी ऑप्शन. 2 1 3. 360 degree is same as 0 degree. Approximate value of the gain margin. तो बेटा when polar plot crosses negative real axis, that is omega PC. So what is the gain? 0.33. So gain margin is 1 by gain. It will be 3. 3 आएगा. Okay, we have to plot the magnitude and the phase for different type of system. So it does not enclose -1. It is stable. Less stable. इनमें से ना एक -1 को क्रॉस करेगा. Marginally stable. Unstable. अब मार्जिनली स्टेबल में क्या होता है ना बेटा, marginally stable is the undamped system, it is 2. Marginally stable is the undamped system, that is 2. This is type 1 order 3 all the systems. Okay. बात है बाकियों का प्लॉट आप कैसे करोगे. अंडर डैम्ड ओवर डैम्ड से तो हो जाता है, बट ये स्टेबिलिटी पे बेस्ड है. 2 आ रहा है ना, ठीक है. इसका यानी कि पोल राइट हाफ में जा रहा है. पोल राइट हाफ में अगर गया तो फेस प्लॉट पे क्या असर पड़ेगा. देखो ये 3 और 4 एक जैसा है, बट पीक वाला ना 3 में ज्यादा है. तो पीक 3 में ज्यादा है तो इसका 3 आएगा, इसका 4 आएगा. क्योंकि जो कम स्टेबल है उस पर ज्यादा पीक मिलेगा, तो इस वाले का 1 आ जाएगा। 4 3 2 1। ओके, एज स्टेबिलिटी रिड्यूसेस पीक इंक्रीजेस। ओके, at 0 this is tail, angle of tail is -180, type 2, this is head, angle of head कितना आ रहा है ये, -270, तो -450 आ रहा है। तो कायदे से ऑर्डर शुड बी 5। तो यहाँ ऑप्शन इनकरेक्ट है बेटा, सारे ऑप्शन एक ही छप गए हैं। ठीक है, इट शुड बी टाइप 2 ऑर्डर 5। Now, polar plot of a frequency response is shown transfer function. So angle at tail is 0, so type is 0. So order is 2. Okay. So at omega equal to 0, magnitude is 1, DC gain is 1. पहले तो DC गेन ही 1 आना चाहिए। So at omega equal to omega n, it is k by 2 j omega n. So magnitude is k by 2 omega n and phase is -90. So k by omega n square 1, k is omega n square. तो इसमें ना कोई भी मैच नहीं कर पाएगा आपका, जो प्लॉट दिखा रखा है उसके हिसाब से नन ऑफ दीज विल बी मैचिंग। ESE 2007, the system is which of the following? तो बेटा -1, 0 lies to left while traversing polar plot, therefore not enclosed and it is stable. स्टेबल आ जाएगा। It is stable provided the value of k is type 1 order 3 omega PC is geometric mean of the corner frequency. So gain at omega PC now this should be less than 1. तभी सिस्टम स्टेबल आएगा। Then your system will be stable. अगर गेन आपका 1 से कम आता है तो ओमेगा पीसी, गेन क्रॉसओवर ESE 2007, gain crossover means magnitude is 1, so it is root k. चलिए नेक्स्ट, रेजोनेंट पीक एंड पीक ओवरशूट आर अ फंक्शन ऑफ जीटा. यस, इट इज 1/2 जीटा 1 minus जीटा स्क्वायर e to the power minus pi जीटा 1 minus जीटा स्क्वायर. Resonant frequency is natural frequency. For zeta, no. Higher the resonance peak, higher is the peak overshoot. जीटा ग्रेटर देन 0.707 के लिए ना आपकी जो रेजोनेंस फ्रीक्वेंसी होती है वो एग्जिस्ट ही नहीं करती, या आप कह सकते हो डीसी होती है. फॉर मिनिमम फेज सिस्टम टू बी स्टेबल, both gain margin and phase margin should be positive. For non-minimum phase with pole in the right half, this criteria reverses. अगर नॉन मिनिमम फेज होगा जिसका पोल राइट हाफ में है तो गेन मार्जिन फेज मार्जिन नेगेटिव आने चाहिए फॉर स्टेबल. Nyquist plot passes through -1, 0. Phase margin is 0. ESC 2008. This is marginally stable. Slope of a asymptotic Bode magnitude plot is integral multiple of plus minus 20 dB per decade or 6 dB per octave. Okay, if the open loop transfer function has one pole in the right half, closed loop system will be stable if n is 1. So once in anti-clockwise direction. ESC 2008, low frequency and high frequency. So low frequency is basically -20 dB into type. Therefore, type is 3. D. Which of the following statement are the domain frequency domain specification? Phase margin, gain margin, bandwidth. These three are frequency domain. ESC 2009. Error in the magnitude at the corner frequency. Remember this, at corner frequency for nth order pole or zero, what is the meaning of error? The difference between actual value and the approximate value using Bode plot. जो एक्चुअल ट्रांसफर फंक्शन से आएगी और जो बोडे प्लॉट से आएगी उसका डिफरेंस. ESC 2009, slope of the line due to 1/j omega. This is -20 dB per decade because this is a first order pole. So slope is always -20 into order. Last question, initial slope of a type 2 -40 dB. For a type n, the slope is like this, -20 into type. Okay, so that's it बच्चों. Now I'll see you around 11:30, 11:45 again for one more session based on control system. Okay, एक और सेशन करेंगे. We will complete frequency response and we will move on to controller and compensator. Thank you.